Hi, so this circuit that we're going to be looking at today involves something known as a flex sensor, which is this long piece right here. It also involves something known as a servo. So just looking at the design on the actual circuit, we've got our 5 volt is this red wire coming in to supply our power to our breadboard. And then we have our ground, the black wire supplying the end of the circuit, right? And then we have our flex sensor, which is very similar to other sensors we've been discussing. It's technically a resistor, and so it's going to be taking a range of input. And so we want to make sure that we hook that up to our analog pin here with the green wire. And so our flex sensor here is connected to row 20, and our analog pin is also connected to row 20. So just like with our other sensors that we've looked at, like the photo sensor, this flex sensor has to work with another resistor to create a voltage divide. And so it is able to read a range of outputs, a range of inputs, and then deliver a output. So here, our other resistor here, this is our 10K resistor, and we have it connected to the flex sensor in row 20, and then we also have it connected to the voltage. So the 5 volts are going to travel through this wire, the yellow wire, through the resistor, and then go into our flex, and then our flex is also connected to our ground. So the cool thing about the flex is that it's coated with a certain conductive material, and when you bend this little strip of conductive material, it receives an input from that being bent. So when it's straight up, it reads a certain resistance, and then you can bend it at different levels, and that creates a different input. So what we're going to do in the code is we're going to code this resistor to read a certain input and then release the output. And the output is going to be our servo here turning. And so we're going to want the servo to turn from 0 to 180 depending on how much the flex sensor is being bent. And so our servo here is connected. It's got to have a power connection to our 5 volt. It also has to have the ground connection to finish the circuit. And then finally our signal is going to be connected to our digital pin of 9. So here's our code we'll look at, and here's a great little explanation of what the flex sensor is, that it's this plastic strip that has conductive coating, and when you bend that strip, the particles in that coating get further apart, and that causes this increase in resistance. And so it's really interesting. You could use this flex sensor for a lot of different things. Okay, so just like with any code, you have to do your definitions at the beginning, right? So we're going to create servo as an object, and that will be named servo1, okay? And then we're also defining that the analog pin will be the flex sensor, so constant flex pin in the 0 analog setup. Okay, so then we're also going to set our servo 1 to pin 9. Now we're going to start our code with making sure that our input is going to be our flex sensor and our output is going to be our servo position. So our flex position is going to be analog read because we have it in our analog pin. And then we also have to take into consideration the map function that we've used before. And this is because the sensor resistor won't be able to give us that full 0 to 5 volt range. So using the map function is a way to reduce that, right? So the flex sensor is actually only 600 to 900, whereas that analog pin can read 0 to 1023. And so we want to actually reduce that all the way to the servos range of 0 to 180 because that's going to be the output, right? So that's what that map function and constraint function are allowing us to do. So instead of the initial 600 to 900, we're going to be putting it within the 0 to 180. So these serial prints are actually to help us kind of do the debugging in the program, because all we can see is the output, right? So there's a lot of the times if it wasn't working, we wouldn't really know what was happening or what was wrong, and we'd have to go through a lot to figure out like what's happening on this little tiny board. But these serial prints allow us to kind of make sure that it's tuning the flex resistor even if there is a range outside of the 600 to 900, and then when we're setting it to the 0 to 180. So everything here is allowing us to kind of look for any issues. And what's really interesting is that you can click this little magnifying glass icon within the Arduino software to view that. So I actually have mine set up right now. So right now I'm not touching the flex sensor, and this is what it's reading, right, on that little magnifying glass up at the top. But once I start to bend it, you can kind of see what's happening. So it's going up to 180 and then capping. I don't know if you guys can see how fast that's moving, but it's allowing it to be capped at that 180 mark, and I can see my servo turning. So bending and not bending, and I can even actually bend it the other way and it will go lower. Okay, so that's it. I'll run the simulation so you can see kind of what it's supposed to look like. So here is our flex sensor. Our servo went to its initial position, and then here we go, bending, and it's moving. Okay, it'll stay there until we go back. I can take it all the way to 180, and then we can go back to 0. Okay, hope this helped.